Remember that feeling seeing those first Hubble pictures?
Yeah.
It's like the universe just decided, hey, I'm going to share my photo album.
Right.
And now with JWST, it's even better, sending back even more incredible stuff. But here's the thing.
Yeah.
Even with all that, we're still just scratching the surface of what's out there.
It's true, yeah. It's like we've been listening to this symphony, but only with a handful of instruments, And now we're about to get the whole orchestra.
Okay, I like that analogy. So walk me through it.
Okay, sure.
What are we missing?
Imagine, like, trying to understand a whole art exhibition. Right?
Okay.
But you can only see one color of the paintings. You'd miss so much. The full story, the little things, the hidden stuff. The universe is kind of like that.
Yeah.
To really get it, we got to see it in every wavelength of light.
So it's not just about bigger telescopes, it's about having the right tools for the job.
You got it.
Yeah.
And this Physics World article we're looking at today, it lays out a plan for a whole new generation of telescopes, each one fine-tuned for a specific type of light. And when we put all that data together, that's when it gets really cool.
Okay, so the ultimate collab. The article calls it a great observatory. Is that the idea?
Exactly. It's like an orchestra, but with telescopes, each one playing a part to make this huge symphony of data.
So we have ones for infrared, X-rays, even radio waves, all working together.
Exactly. It's about layering things, getting a richer picture. But just like any big project, there are challenges. It reminds me of, the whole JWST situation.
Oh, yeah.
Groundbreaking, but all those delays, the budget, oof.
Talk about a development cycle, right. But what did we learn from all that?
Well, JWST taught us we need ambition, but also got to be practical. These huge projects, they can easily turn into winner takes all. And then other important missions get sidelined or delayed.
So how do we avoid that in the future? This article talks about a two-pronged approach.
Right, that's key. Yeah.
So is that the answer?
It's a big part of it. So the idea is to invest in those flagship missions, the big ones like JWST, but also, and this is important, smaller probe class missions too.
Okay, so balance out those home runs with some well-placed base hits.
Exactly. Push the boundaries, but manage the risks and the resources too.
Love this strategy. All right, so let's start with those big swings. What flagship missions are on the horizon?
Well, at the top of the list, a successor to Hubble.
Oh, wow.
Imagine a telescope so powerful it could directly image exoplanets.
No way.
Earth-sized planets in those habitable zones around other stars.
Hold on, wait. We're not just talking about detecting them indirectly now, right? We're talking actual images.
You got it.
Wow.
But to do that, we need a massive jump in technology, particularly with something called coronagraphs.
Coronagraphs, right. Remind me again what those are.
Okay, so imagine trying to spot a firefly, right?
Okay.
But it's right next to a spotlight. That's what it's like to see a planet next to a star.
Oh, yeah, I see what you mean.
Coronagraphs are like high-tech shields. They block that blinding starlight, so we can actually see those dim planets orbiting around it.
Wow, starlight blocking. No wonder it's a challenge, but that's what makes this so exciting. The possibilities, an actual picture of another Earth. That's game-changing.
For sure. But we can't forget about the rest of the light spectrum, right?
Right, of course.
The article also talks about how important X-ray and infrared telescopes are. In fact, there are two proposed missions, nicknamed FIRE and SMOKE.
Okay, I see what they did there. Very catchy. So what kind of mysteries are FIRE and SMOKE going to tackle?
All right, so FIRE, that's the X-ray one,
Uh-huh.
would be perfect for studying the most energetic events. Black holes, gobbling up matter, or those massive explosions when stars are born.
So FIRE is all about catching those quick, powerful events.
Yeah, stuff that happens in a cosmic blink.
That's amazing.
And then there's SMOKE. That's far infrared.
Yeah.
Perfect for looking through those massive gas and dust clouds, the ones that block our view of star formation.
So FIRE gets the fireworks show, and SMOKE sees how the stars are born. It's incredible how they work together.
Right.
It's like we're getting a whole new generation of these great observatories, building on what we learned from Hubble, Chandra, Spitzer, all of them.
It is, yeah. And that's not even mentioning the ground-based telescopes.
Oh, right.
They're getting some amazing upgrades, too. They're crucial to this whole orchestra of observatories.
Okay, so we're already talking about groundbreaking science, mind-blowing technology, and we haven't even touched on what's happening here on the ground yet. Tell me more about that.
Ground-based telescopes, those are the ones like here on Earth, right?
Right, yeah.
So how do those fit in when we're talking about seeing things billions of light years away?
That's a good question. So ground-based telescopes, they don't have it easy. They're stuck down here with our atmosphere.
Right.
But they've got other advantages.
Okay, like what?
For one, they can be way bigger, Like way bigger than anything we could launch into space.
Okay, now you've got my attention. How much bigger are we talking? This Physics World article mentions a couple of cool projects. There's the 30-meter telescope, for example.
30 meters, the name kind of gives it away.
Right, a mirror that's 30 meters across. Think about all that light it can gather.
30 meters, that's huge. My whole house could fit in that thing.
It really puts things into perspective. And then there's the giant Magellan telescope. It's a different approach, but just as impressive.
Oh,
Instead of one massive mirror, it combines 7 of them, each one over 8 meters wide, all working together. Basically, it's like one giant telescope with a diameter of almost 25.5 meters.
so it's like 7 telescopes in one. That must be some serious engineering.
Oh, absolutely.
But what can these supersized telescopes see that, say, Hubble can't?
It's not always about seeing different things. It's more about seeing the same things, but with way more clarity.
Okay, I think I see what you mean.
Think of it like listening to music on a crappy old radio versus like a top-of-the-line sound system, you know?
Yeah.
These telescopes, they gather so much more light, which means they can see those faint objects, the really distant ones, and the details are much sharper.
So it's all about that resolution, seeing those little details that might tell us something big.
Exactly. And because they're on the ground, they're easier to maintain, easier to upgrade.
Right?
So as new tech comes out, we can implement it faster. Keeps these observatories at the cutting edge.
It's like having a state-of-the-art lab that's constantly evolving. This Physics World article, it mentions something called the Next Generation Very Large Array. That sounds intense. What's that all about?
Ah, that's for radio astronomy, yeah. It's a whole other way of observing the universe.
Radio astronomy. So not even light anymore.
Right, exactly. So picture this. Hundreds of radio dishes spread out over a huge area, all working together to create these crazy detailed images of the radio sky.
Whoa, okay.
This new array would be revolutionary for studying things like pulsars.
Pulsars, right? The spinning neutron stars.
Yep, those are the ones. And even the faint afterglow of the Big Bang itself.
Wait, seriously? We could see that?
It's called the cosmic microwave background radiation, but yeah, essentially.
Mind-blowing. It's amazing all the different ways we've figured out to observe the universe. Each one shows us a different piece of the puzzle. But with all this talk about new telescopes, what happens to the old ones? Like Hubble, Chandra, are they just going to be retired?
Not at all. As long as they're working, as long as they're doing good science, they're still super valuable.
Really?
Yeah, even if newer telescopes are more powerful in some ways.
Right.
The older ones, they often have unique capabilities, things that make them irreplaceable.
Okay, that makes sense. It'd be silly to just get rid of a perfectly good telescope, especially if it can still make important observations.
Exactly. And the article even talks about a possible ultraviolet probe mission. It wouldn't be a flagship mission, more like a smaller, focused project,
Okay.
but it can still make huge contributions, studying exoplanet atmospheres or how galaxies change over time.
I like it. It's all about using the best tool for the job, whether it's a massive ground-based observatory or a smaller, more specialized space telescope. But with all these amazing projects in the works, I gotta ask, how realistic is this? This all sounds incredibly expensive.
Yeah, no kidding. Space exploration has never been cheap.
True, very true.
And these new telescopes, we're talking next-level ambition here.
It's a big investment, no doubt. But I think it's important to remember what we get back from that, a
Wow.
deeper understanding of, well, everything. The universe, our place in it.
Investing in our future, like you said.
Exactly.
But it takes time, too, right? I mean, this article mentions these telescopes potentially still going in the 2070s.
Wow, yeah.
That's a timeline most of us can't even imagine.
It's a long game, for sure. But that's part of what makes these projects so incredible. They're not just for us, you know?
What do you mean?
It's about leaving a legacy, a path of discovery for future generations.
It's like planting a tree.
Yeah,
right?
you might not get to enjoy the shade, but you know it'll be there for someone someday.
I like that.
It's a powerful thought.
It really is. It's at the heart of what makes these things so inspiring, I think. Contributing to something bigger, something that'll outlive us all. This quest for knowledge.
And imagine, right, by the 2070s,
Yeah.
we could have pictures of other Earths.
It's mind-boggling.
Maybe even proof of life out there.
Who knows what we'll find.
It's almost impossible to grasp what those discoveries would mean. It changes everything, our whole understanding of the universe.
That's the most exciting part. Those moments where we have to rethink everything we thought we knew.
Those aha moments.
Exactly. The ones that change our perspective make us ask even bigger questions.
It's like that feeling when you finally get something you've been stuck on,
Yes.
but on a cosmic scale.
Exactly.
We've talked about the what and the how of these future telescopes. But the big question for me is, what does it all mean?
The million-dollar question.
Right.
What will these discoveries tell us about the universe? How will they change how we see ourselves? No one knows for sure. But one thing's for certain.
What's that?
The knowledge we get from this, it has the power to change us profoundly.
So it's not just about what we find out there in space, it's about how those discoveries change us here on Earth.
Absolutely. Expanding our horizons, literally and figuratively. Inspiring future generations to never stop questioning, to never stop exploring.
Beautifully said. That sense of wonder, of exploration, it's what makes all this so captivating. Thank you so much for taking this deep dive with us. It's been incredible.
It was my pleasure. Remember, keep looking up.